Hello guys, today we'll see the design procedure for a chain drive. Now we have a number of types of chain drives like roller drives, bush drives or inverted truth drives. Let us directly jump onto the procedure for designing the drive. We have 11 different steps. I'll be going through them step by step. We'll be selecting the preferred transmission ratio, the number of truth on the pinion sprocket, Z2, the service factors, design loads, bearing stresses, and finally the diameter of the sprockets. So jumping onto the question through which I'll explain all the 11 steps. We need to design a chain drive to run a compressor from a 11 kilowatt electric motor running at 970 rpm, compressor speed being 330 rpm. So both N1 and N2 are given. Compressor operates at 16 hours per day. The center distance should be about 500 mm. The chain tension can be adjusted by shifting the motors on slides. So step 1 is select a preferred transmission ratio. So we know the formula I is equal to N1 by N2. Since both the values of N are given, we will not be standardizing the value of I and let it remain as 2.93 only. If we want to standardize the value of I, we can very well go and look at page number 7.74. The data book will be used is the design data book compiled by PSG College of Technology. So yes, where was I? If we want to standardize the value of I, on page 7.74 we have preferred transmission ratio I 1, 1.12, 1.24, 1.4, but we'll be only needing that if both the values of N aren't given. Coming to step 2, select the number of teeth on the pinion sprocket. So on the same page 7.74 we have a table named recommended Z1. Since our transmission ratio is 2.93, which lies between 2 and 3, therefore our Z1 lies between 27 or 25. So let us assume Z1 is equal to 25. Third step is finding Z2. We have this formula on the same table. Z2 is equal to I times Z1. Therefore Z2 becomes 73.25. Now we see under the formula we have a condition Z2 max should be 100 to 120 only. So our value of Z2 is on the safer side. Step 4 is determining the range of chain pitch. Now on page 7.74 from the formula center distance A mm just above the last table. So optimum center distance A is equal to 30 to 50 times P. Now P is the pitch. So the value of A given in our questions was 500 mm. Therefore, we'll have two values of P here. P max, which is 500 divided by 30, which gives us 16.66, and P min, which is 500 divided by 50, which gives us 10. Now in this data book, we have three values of pitch through which all the datas are solved. This can be seen just above the formula on the table. We have the value of pitch as 9.525, 12.7 and 15.875. Now we should always consider the maximum value and then standardize this value. So 16.6 is maximum, and standardizing this we'll be getting pitch is equal to 15.875. Step 5 is selecting the type of chain, that is simplex chain, duplex chain or triplex chain. So we have a big table over here sprawling 3 pages. Let us directly see the column where pitch is 15.875 and select any value over there. So let me for example select 10A2 DR50. Here the pitch is 15.875 mm given on page number 7.72. Hope you guys found that value. It's the fourth value from the top on page 7.72. We'll be needing this row quite often to solve the further steps. Step 6 is evaluating the total load, that is summation of tangential, centrifugal and tension due to sagging of chain, given on page number 7.78. Now P tangential can be found with the formula 1020 into n divided by v. Just keep in mind a few of the books have misprint and the 0 has been shifted towards the top. So it is 1020 into n divided by v. Here n is in kilowatts. So looking at the question, we had the compressor from an 11 kilowatt electric motor. To calculate V, we have the formula Z into P into N divided by 60 into 1000. Now 1000 is to convert meter into mm. So Z1 is 25, P is the pitch which is 15.875 and N is 970 RPM. So this comes out to be 6.416 and the value of P tangential comes out to be 1748.7 newtons. Now P centrifugal can be calculated by the given formula WV square divided by G. I can any day write W by G is equal to M. Also, the value of M is given on page 7.72, the big table, as 1.78 kgf. And we just calculate the value of V from P tangential. Thus, we got the value of M from page 7.72 and the value of V from this formula. Therefore, P centrifugal comes out to be 73.27 Newton. What is left is P, that is tension due to sagging of chain, given by the formula K into W into A. Now, A is 0.5 meters or 500 mm. W can be written as mg or 1.78 into 10, that gives us 17.8 kgf, and we find the value of k from the table on 7.78, coefficient for sag k. We'll be choosing the horizontal coefficient because nothing is specified in the question, so always choose as the horizontal chain drive, so the value of k comes out to be 6. Therefore ps is 53.4 newtons. Therefore, adding all the three, we get the summation of P as 1875.37 Newton. Now comes a tedious part. Page 7.76, Service Factor Evaluation. The value of Ks. So we have 6 different constants here, all of which value are given on page 7.76 and 7.77. So just go through these values and the written part and choose accordingly to the question as to what the value is needed for us. So for example, K1 is 1.25 as we need variable load or load with mild shocks. Now K2 is being selected as 1 because we need adjustable supports, as it was given in the question chain tension is can be adjusted. K3 is 1 because we choose the value AP is equal to 3250p, thus it is 1. K4 we'll be selecting the horizontal because nothing is given in the question, so that turns out to be 1 again. Normally for K5 we select drop lubrication because nothing is given again, so drop lubrication is what we have to choose, and the value of K5 turns out to be 1. Rating factor K6, as we saw in the question, the chain runs for 16 hours per day. Therefore, the value of K6 turns out to be 1.25. Multiplying all of these, the value of Ks comes out to be 1.5625, which can be rounded off to 1.6. Now calculating the design load. This formula is not being mentioned in the data book, so it would be advised to just remember this. So design load is PT into Ks. Now PT we got from step 6 and Ks we got from step 7. Therefore, this value turns out to be 3000.59 Newton. As we all know, we have to include factor of safety in everything. So factor of safety is braking load upon design load. Where do we get braking load from? Page 7.72, the big table. So 4440 kgf can be converted into 44,400 newtons. Therefore, factor of safety comes out to be 14.8 over here. So is this factor of safety correct or not? Let us check from page 7.77 under the table minimum value of factor of safety. So we see for pitch 15.875 and n is equal to 14.8. The maximum RPM the sprocket can sustain is 2000, but as we saw in the question, the given RPM is 970 only. Therefore, our selection of factor of safety is correct. Step 9 says check the bearing stress in the roller from page 7.77 again. So we have the formula sigma is equal to Pt into Ks divided by A. Just mug up this formula. So Pt we got from step 6 as 1748.75. Just remember this is P tangential and not the total load. Ks we got from step 7 and A is the area of cross section given on page 7.72 under the selection of 10A2 DR50. I hope you guys find this. Also it is given in centimeter square, so just convert it into mm square. Therefore, the value of sigma comes out to be 19.98 Newton per mm square. So from the table on 7.77 allowable bearing stress sigma, we see that for RPM 1000 we have the bearing stress as 2.24 kgf per mm square. Converted into Newton is 22.4 newtons. Just remember that the value on the table should be always greater than the value which we calculate over here. So obviously this is coming as a satisfied equation. 22.4 is greater than 19.98. Since all the loads and bearing stresses have been calculated, now let us go to the number of chains in terms of number of links, which is step 10. Now this formula is given on page 7.75. Putting in this formula, we have the values of Z1 and Z2. And what is AP? Now AP, as we see on page 7.75 itself, is A0 by P. A0 is the center distance and P is the pitch. So this gives us 31.4. Substituting this 31.4 in our equation, we get the value as 113.99. So this should be converted into a little larger number and an even number. Just remember the even part. So this turns out to be 116 links. Now if we multiply links with the pitch, we get the total length of the chain, which turns out to be 1.8415 meters. So we have assumed so many values. Finally, let us calculate the corrected center distance of our system. So this formula is also given on page 7.75 only, and the formulas for E and M are also there. So to calculate E, we have LP, which we just found out, Z1 and Z2 we know, which turns out to be 66.87, and similarly we can calculate the value of M also. Solving the main equation for corrected distance, we get the value of A as 516.43 mm. So we got a new value which turns out to be 516 mm from 500 mm, which was originally given in the question, because we have assumed so many things along the way while solving the question. Finally, let us summarize by calculating the pitch circle diameter of sprockets. So this formula is given on page 7.78. Pitch diameter of sprockets. Diameter of small sprocket D1 is P divided by sine 180 by Z1. We know the value of Z1, so we can find the diameter of small sprocket. Similarly, we can find the value of larger sprocket 2, which turns out to be 370.25 mm. Also, one last thing which is left, pitch circle diameter with maximum roller diameter included. Now roller diameter is given as 10.16 on page 7.72, the big table. So we have a formula D01 is equal to D1 plus 0.8 times DR. So this gives us 126.66 plus 0.8 times 10.16. So the final value of pitch circle diameter is 134.78 mm. Similarly, for the largest sprocket, it is 378.378 mm. Hope you guys understood the basic concepts of chain drive. Feel free to ask any of your doubts in the comment section. Do subscribe to our channel so that we get encouraged and provide you with more and more updates on so many different things. Thank you. Robometrics.